Hi all, welcome back. In today's session, we will be diving into the world of hypothesis testing using SAS. Specifically, we will focus on performing a one-tailed t-test in SAS. So let's get started. The t-test is one of the most common hypothesis tests in statistics. The t-test determines either whether the sample mean and the mean of the population differ or if two sample means differ statistically. The t-test distinguishes between one sample t-test, independent sample t-test, and pair sample t-test. The choice of which t-test to use depends on whether one or two samples are available. If two samples are available, a distinction is made between the dependent and independent sample. In this tutorial, we will find everything about the one sample t-test. The one sample t-test is used to test whether the population differs from a fixed value. So the question is, are there statistically significant difference between a sample mean and a fixed value? The set value may, for example, reflect the remaining population percentage or a set quality target that is to be controlled. Let's imagine you are aiming to investigate whether the average sales of a specific product in your company aligns with an anticipated value of $10. In this pursuit, you have taken a random sample of 50 customers and executed a t-test. By comparing the actual sales figures from this sample with the expected value of $10, you are able to rigorously gauge whether the product sales performance matches the set benchmark. This t-test approach provides a statistical basis for your assessment. There are two kinds of hypotheses for one sample t-test: the null hypothesis and the alternate hypothesis. The alternate hypothesis assumes that some difference exists between the true mean and the comparison value, whereas the null hypothesis assumes that no difference exists. The purpose of the one sample t-test is to determine if the null hypothesis should be rejected given the sample data, whereas the alternate hypothesis can assume one of the three forms depending on the question being asked. If the goal is to measure any difference regardless of a direction, a two-tailed hypothesis is used. If the direction of the difference between the sample mean and the comparison value matters, either an upper-tailed or a lower-tailed hypothesis is used. The null hypothesis remains the same for each type of the sample t-test. As a parametric procedure, the one sample t-test makes several assumptions. Although t-tests are quite robust, it is good practice to evaluate the degree of deviation from these assumptions in order to assess the quality of the results. The one sample t-test has four main assumptions. Number one, the dependent variable must be continuous. Number two, the observations are independent of one another. The dependent variable should be approximately normally distributed. And the last one is the dependent variable should not contain any outliers. Let us now proceed with the examination of the dataset that will serve as the foundation of our analysis. The dataset under consideration is GapMinder dataset containing a total of 56 distinct observations, each corresponding to a distinct country within the dataset. To facilitate this investigation, we will use the Proc content procedure in SAS, a utility that furnishes a valuable insight into the critical attributes such as the number of observations, the data type of the variable, and additional pertinent details. Proc contents data equal to GapMinder. By the way, GapMinder dataset is easily available over the internet. Order equal to var num, no details, and run. As you can see, in GapMinder dataset we have 56 observations, and these are the variables, and these are the data type associated with those variables. The variable of interest for us is ALC consumption. The full form is alcohol consumption. To grasp the dataset essence, we will use the proc print procedure to showcase its top 5 records, offering valuable insights into its characteristics. Proc print data equal to GapMinder ops equal to 5, no ops, run. And you can see here this is how our data looks like, and as I have said earlier, the variable of interest for us is ALC consumption. We will now proceed with conducting a descriptive analysis on the GapMinder dataset accompanied by an assessment of the assumption underlying the one sample t-test. Our focus pertains to the variable ALC consumption, denoting alcohol consumption for each country. We will use Proc univariate procedure. We aim not only to compute essential descriptive statistics but also to delve into the comprehensive insights regarding the variable's distribution characteristic. For a more comprehensive understanding of the Proc univariate procedure, I will post the link of the video within the description section. Our objective is whether the distribution of ALC consumption aligns with the normal distribution or not. We shall now write the code and explore the alcohol consumption patterns. Proc univariate data equal to GapMinder, where ALC consumption histogram, ALC consumption normal, mu equal to EST, sigma equal to EST, and kernel. Inset skewness, kurtosis, position equal to any, prop plot, say consumption, I'll copy and paste this piece of code as well as title, descriptive analysis on alcohol consumption, run. Now let's run the code. Our area of interest is to find out whether the alcohol consumption follow the normal distribution or not. Here you can see the normal probability plot illustrates a 45-degree line that signifies the expected distribution for the data from a normal distribution. The data points depicts as circles diverge noticeably from this particular line, indicating a significant deviation from a normality. This is further reinforced by the p-values from both the KS and the Anderson-Darling test. So you can see here the KS test and the Anderson-Darling test, both below 0.05, leading to the conclusion that the alcohol consumption does not adhere to the normal distribution. However, a noteworthy consideration arises. The violation of this assumption is often trivial due to the application of the central limit theorem. This theorem stipulates that with a sufficiently large sample size, typically exceeding 30, the distribution of sample means tends to approximate a normal distribution, irrespective of the underlying population distribution. Consequently, for ample sample sizes, the t-test can be employed without a normality test. Now we are going to conduct the t-test in SAS using the Proc TTest procedure. Our next course of action involves the formulation of the hypothesis, and they are: the null hypothesis is the mean value of alcohol consumption is equal to 7, and since we are going to conduct the two-tailed test, the mean of alcohol consumption is not equal to 7 is our alternate hypothesis. Now we are going to call the Proc TTest procedure Proc TTest procedure on the GapMinder dataset, and we are going to specify alpha equal to 0.05. This alpha level signifies a 5% acceptance of the risk committing a type 1 error, which is to wrongly reject the null hypothesis when it is true. Additionally, we shall define our null hypothesis as H0 equal to 7. Furthermore, our interest extends to the exploration of the QQ plots and the histograms, and for that we will invoke the plot option. Plots show null equal to interval, and since it is two-sided test, we will call side equal to 2. Now we will call our variable of interest ALC consumption. Let's put up the title testing whether the mean of alcohol consumption is equal to 7. Run. Now let's analyze the Proc t-test output. You can see the summary statistics such as number of observations. They are 56. The mean value is 9.4291. Standard deviation is 5.2667. Standard error is 0.7038. and min and max value. It also provides the confidence interval of alcohol consumption around the sample mean and sample standard deviation are reported. Notice that 95% confidence interval around the mean does not include the null hypothesis value of 7, which implies that we can reject the null hypothesis that the mean value of alcohol consumption is 7. Moreover, p-value that is reported in the third box is less than 0.05. Hence, we can conclude that the mean value of alcohol consumption is not equal to 7. You can see, since we have called the plots option, it yields a set of analytical visuals including histograms, box plot and QQ plots, contributing to a comprehensive analysis of alcohol consumption patterns. Let's conduct another alternate hypothesis, that is the mean of alcohol consumption is greater than 7. Let's copy and paste the above code and change the side. Let me copy and paste first. And here we have to change the side to U. And that's it. Now let's run the code. And as you can see here, since p-value is less than 0.05, and hence we can reject the null hypothesis and can say that the mean value of alcohol consumption is greater than 7. Let's conduct our last alternate hypothesis, that is the mean of alcohol consumption is less than 7. Let's copy and paste the above code and change its side to L. Now let's run the code. And you can see here, since p-value is greater than 0.05, and hence we can conclude that we failed to reject the null hypothesis and conclude that the mean value of alcohol consumption is greater than 7. In conclusion, our exploration of the Proc t-test procedure provides valuable insights into the hypothesis testing and its application. By delving into the summary statistics, confidence interval, and graphical analysis, we have gained a deeper understanding of its utility in a statistical assessment. Thank you for joining this tutorial, and we look forward to sharing more insightful content with you. Thanks for watching.